Okay, so here we are. We're into our third video, and in this video, we're going to look at rule number 3 and rule number 4 for exponents. Rule number 3 and 4. So this is the 0 power rule and the negative power rule. So with that said, let's take a look at our objectives and get started. You're going to recognize these objectives. They're very similar to the previous video, and they're going to be similar to the video that comes after this one. Excuse me. Know the 0 power and the negative power rule, and then be able to simplify expressions that have all 3 of those rules happening within them, or I'm sorry, all 4, can't count, all 4 of those rules happening in them at the same time. Okay, so let's get started here. I'm going to approach this one slightly different than we did in the last 2 videos. There have been, over the centuries, a lot of different definitions presented for what mathematics is. You know, some people would say it's the study of numbers, but then you'll throw in geometry and all of a sudden, well, maybe numbers is too narrow of a focus. And so some people, well, there's lots of definitions. My favorite definition of mathematics that I've heard or read or that's been proposed over the centuries is that math is the study of patterns, the study of patterns. And so I want to start this particular video by looking at a pattern. This happens to be a pattern that's called a geometric pattern. You don't have to know that word, but as a side note, we will study geometric patterns later in our class. So this is a geometric pattern. And so my question for you is, as I move down this list of numbers, what is the pattern that takes me from the number up here to the number that's underneath it? In other words, what did I do to get from 32 to 16 that I also did to get from 16 to 8, and I also did to get from 8 to 4, and then from 4 to 2? So what is my pattern? If you need to pause the video to think about it, go ahead and do that, but maybe you've got the answer right off the top of your head. Either way, I'm going to tell you the answer right now, and that is that I'm dividing by 2 every single time. 32 divided by 2 is equal to 16. 16 divided by 2 is equal to 8. 8 divided by 2 is equal to 4, and 4 divided by 2 is equal to 2. Okay, now you've done problems like this in middle school and elementary school. The typical next question that your math teacher would normally ask is, what comes next? And they might have you fill in the next maybe 2 or 3 even numbers that would come next. So if we continue this pattern of dividing by 2, what would be the next number in our pattern? Excuse me. Well, 2 divided by 2 is equal to 1. So the next number in my pattern would be 1. And if I did this again, then 1 divided by 2 is equal to 1/2. And if I did that again, then 1/2 divided by 2, ooh, it's starting to get a little trickier here. 1/2 divided by 2, do you know that one? It is 1/4. 1/4 is 1/2 divided by 2. Okay, now you might be looking at this and thinking, Mr. Root, what does this have to do at all with exponents? Well, here is where there's a little bit of method to my madness. I happen to know, because I've studied math long enough, that 32 just happens to be exactly equal to 2 raised to the 5th power. And 16 happens to be exactly equal to 2 raised to the 4th power. And 8 is exactly equal to 2 raised to the 3rd power. And so what you can see is happening here is every time I divide by 2, my exponent goes down by 1, which should make sense because we know the quotient rule, right? If I take 2 to the 5th and divide it by 2, well, there's only 1 2 here. So having only 1 2, that's the same as saying 2 to the 1st. Then the quotient rule says, take those 2 exponents and subtract them. And sure enough, that's the answer I get, right? So this pattern should make sense to us, that it works this way. So this is good. This is nice. And then this also brings us to the rules for today. My pattern for the exponent is that every time the exponent goes down by 1. So if I continue following that pattern, then 1 should be exactly equal to a 2 raised to the 0 power, because that's what would happen if this went down by 1. And if I was at 2 to the 0 power and I went down by 1, then that means 1/2 should be exactly equal to 2 raised to the -1. And if I went down by 1 again, that means 1/4 should be exactly equal to 2 raised to the -2. Okay, so think about this for just a second. If we use this pattern, and as a side note, this is the correct pattern. I'm not bringing, weird math to you or whatever. This is how the 0 power and the negative power rule work. Can you use this pattern to extrapolate out and predict what 2 to the -3 power is going to be? If you need to pause the video to think about that, go ahead and do that. But let's check your answer. Now, I know what the answer is, but because we do need to be able to do these types of problems on calculators, and because you might not trust me, I'm going to do this 2 raised to the -3 power on my calculator just to make sure that we're getting the right answer, we're comfortable with it. So I have 2, and then remember, to get the exponent, I'm going to use this caret button here. So I've got 2 caret -3, okay? Now, technically, that -3 doesn't have to be in parentheses. It automatically put it up in the exponent. So I'm good there. Push enter. Oh, I got a weird decimal. Now what do I do with that? Well, that's okay. You might remember that your calculator can automatically switch a decimal into a fraction. The way you do that is you push the math button. The math button will open up this menu with all these different options. And the very first option is the option that makes fractions. So after I push the math button, I just push enter. It's going to take that answer and make it into a fraction. So now I push enter again. Look at that. It's 1/8 is my answer. So 2 to the -3 power, that is the same as a 1/8. Okay, so there is my pattern. All right, so let's step back and look at this pattern here. And that'll give us our answer for what do 0 powers and negative powers do. Well, let's start with the 0 power for a second. The 0 power right here gave me something that was equal to 1. Now think about this. Should this change in any other situation? Let's say instead of 2's, let's say I had 5's. So I had 5 squared, 5 to the first, 5 to the 0, 5 to the -1. Let's think about these. Well, we know that 5 squared equals 25. 5 to the first equals 5. So my pattern is I'm dividing by 5. What does 5 divided by 5 equal? Well, that equals 1. So that still works. The pattern still works. It hasn't changed at all. And then if I divide that by 5, 1 divided by 5 is going to be 1/5. And so that pattern still works. It's not changing. Okay? So what I end up with is this very nice, simple rule that pretty much mostly everything raised to the 0 power equals 1. Now, I do say pretty much mostly because there actually turns out to be one exception. There's one thing that you cannot raise to the 0 power. And the reason you can't raise it to the 0 power is because this pattern is built on dividing. And there is one number that you're never allowed to divide by. What number can you not divide by? 0. You cannot divide by 0. So here's what the 0 power rule says. The 0 power rule says, it says any number, or actually anything, it could be variables, it could be whatever, anything except for 0 raised to the 0 power equals 1. Now, if you wanted to be really fancy, this is probably something we wouldn't test you on in our class, but for the sake of completeness, what happens if it is a 0 raised to the 0 power? Well, the second half of this rule says that 0 raised to the 0 power is an undefined expression. In other words, that just doesn't have an answer. 0 raised to the 0 power just simply does not have an answer. And I can do that on my calculator and verify that. If we look at my calculator and I type in 0 caret 0 and push enter, it gives me an error. And the error, it's a little bit hard to read on the screen, but it says the error is because this is not allowed to be in my function. Okay, I'm not allowed to have that. I'm not allowed to do 0 to the 0 power. All right, so this is the 0 power rule. Basically, we'll summarize this by saying that anything to the 0 power equals 1. Okay, we'll have to remember that there's an exception, but more or less, anything to the 0 power equals 1. So there's our 0 power rule. And then the next half of that is the negative power rule. So notice what's happening with the negative power. A -1 gave me a 1/2. A -2 exponent gave me a 1/4. A -3 exponent gave me a 1/8. Now here's what I want you to notice. If we go up here and look at our normal exponents, what does an exponent of 1 equal? It equals 2. Interesting, because -1 is 1/2. What does an exponent of 2 equal? Well, it equals 4. Now that's interesting, because a -2 is 1/4. Okay, what does an exponent of 3 equals? Well, that equals 8. How interesting, because a -3 equals 1/8. So what's happening? What we find is that for any situation, if I know what the positive exponent is equal to, then the negative exponent, 2 squared equals 4. There we go. If I know what the positive exponent is, then the negative exponent will be the reciprocal of that thing. Remember, reciprocal is when you take fractions and turn them upside down. So I'm just going to take this fraction, which is 4/1, turn it upside down, that gives me 1/4. So negative exponents make reciprocals, or they make fractions, might be a way that I summarize that. But specifically, the kind of fraction it makes is a reciprocal. And so that's our negative power rule. The negative power rule says negative exponents create reciprocals. Okay, negative exponents create reciprocals. Okay, so let's take a look at 2 quick examples for these rules, 1 for each, or maybe we'll do 3, we'll see. And then we're going to cut this video short there, and we're not going to get to objective number 2 in this video. Remember, objective number 2 was to be able to put all the rules together. I'm going to make a separate rule or video for number 2, because those examples will take a little bit longer. So I think if I put that together with this one, the video would be too long. So let's just do a couple quick examples with these 2 rules, and we'll call it good for this particular video. So here we go. The 0 power rule. Well, the 0 power rule says that I can take anything. So let's be creative here. Let's say I've got x squared minus 3x plus 5 times 2x minus 7, all divided by 32 to the 4th power. Okay, now I don't know about you, but I think that looks pretty ugly. But here's the beautiful thing. I'm going to take that whole entire fraction, that whole dealy-hoo. Oh, look, there's another grouping symbol that's not a parenthesis. Brackets are a grouping symbol that's not a parenthesis. And I'm going to take that entire bracketed set of stuff, I'm going to raise the whole thing to the 0 power. And so the beautiful thing about the 0 power rule is it says anything. It doesn't matter how nasty and ugly this is. All of this stuff raised to the 0 power just simply will equal 1. And I don't have to worry about any sort of work. As soon as I see there's a 0 power, If this is not a 0, then my answer is going to be 1. And it's just that simple. So there's our first example. Let's take a look at our second example, the negative power rule. Okay, so the negative power rule. So let's suppose that they give me some random number. Let's go ahead and do a variable this time. Let's say that I've got 3x to the negative 4 power. Now, I'm going to warn you real quick because you might feel like, oh, I got this. I'm on top of it. There's a little bit of a trick to this one. So maybe pause the video, think about it for a second, get your answer, and then restart the video and let's talk about this. All right, so I'm saying there's a little bit of a trick to this one. So what's the trick? The trick comes from order of operations. And this problem has 2 operations. Obviously, one of the operations is an exponent. But what's the other operation? Well, it's this multiply. I have 3 times x to the negative 4 power. So in order of operations, what comes first? Exponents or multiplies? Well, exponents come first, which means that I have to treat this exponent piece separately than the 3 piece. Those 2 things are separate because the order of operations says I have to do this first and then multiply. I will say it's a very common student mistake for people to try and do 3 to the negative 4 power. I cannot do that because exponents come before multiplies. Okay, so now let's talk about what does this do? Well, negative exponents create reciprocals. So that means I know I'm going to end up with this thing over 1. When I take the reciprocal, now I get 1 over this thing. But because I've used up the negative by making a reciprocal, the negative has disappeared. I've used it up. It's taken care of. Now, if you're not sure where did it go, let's go back to the numbers. It's easier to see with the numbers. Notice here I had a -3. The negative is what made my fraction because the negative told me to divide. And then I ended up with just a 2 to the 3rd power, right? 2 to the 3rd power is what 8 is equal to. 8 equals 2 to the 3rd power. So I've got an 8 in the bottom, which is the same as a 2 to the 3rd power in the bottom. That's a positive exponent now. So as soon as I make this fraction, the exponent turns into a positive down here, and the bottom is just a positive 2 cubed, or in other words, a positive 8. So the same thing happens with this. I use the negative sign to make the reciprocal fraction. That's what the negative sign does. The negative sign makes my reciprocal fraction. And then the exponent now becomes positive because I've used the negative up. And so then the last thing to do is I'm going to multiply these 2 fractions together, which if you want to be really picky and show all your steps, in order to multiply 2 fractions, you have to take the first one and put it over 1. And then I have 3 times 1, which is 3. And I have 1 times x to the 4th, which is x to the 4th. And there's my answer. Okay. Now, as a side note, I would not normally write this, and I wouldn't make you write it either. If you can look at this thing right here, and you know that this thing is going to be equal to that, you're welcome to skip that middle step. Okay. I just want to make sure that we're comfortable with multiplying fractions because we haven't talked about that very much yet this year. All right. So that takes care of the 0 power rule and the negative power rule, and a quick example of each of those. In the next video, we'll take a look at our other learning objective, which is to take all of these rules and mix them together within a single problem, and we'll do multiple examples in the next video like that. Thanks for watching. Make sure you watch the next video too. Have a good one.